Today we're going to describe something that's the formulation of ideal gas equations. First of all, you must understand the concept of ideal gas equations, as we say that it's the equation in which obey all ideal gases. So those gases that are ideal always undergo the ideal gas equations if you basically in part of solving. So through that you can say that this ideal gas equation is formulated from three rows. So you must understand that ideal gases is formulated from three laws. The first one is Charles law. The second one is Boyle's law. And the third one is Avogadro law. So we have three laws that we're going to describe. But the first one we'll say about the Charles law. We know that the Charles law, we say that a volume is directly proportional to temperature when the pressure is kept constant. The Boyle's law, we say that volume is inversely proportional to pressure when the temperature is kept constant. And the Avogadro's constant, we say that a volume is directly proportional to the number of moles. So through these three equations, we can deduce the ideal gas equations. And the ideal gas equations, it seems like that way. You see that PV is equal to nRT. Why this? R is the universal gas constant. This is the mole. N is the mole constant. T is the temperature. V is the volume, and P is the pressure. So through that, now we're going to deduce how it seems like. We're starting by saying that Charles' law is volume is directly proportional to temperature, while the Boyle's law is inversely proportional to pressure, while the Avogadro's constant is directly proportional to number of moles. So through that, now we're going to use only single proportionality, that is the volume is directly proportional to T over Pn. After that, now we're going to remove this proportionality. As I said previously from other discussions, so that when we remove this proportionality, we're going to keep the constant. So it will be volume is equal to constant Nt over P. But understand here, when you put this K here, we don't use as K, we use as R, that is a constant. And this R, it means universal gas constant. This is constant that you can obtain directly, maybe from your calculation, maybe you have given, so this one must be provided. So until then, now we're going to dispute on this, that volume is equal to R Nt over P. Until the end, we cross multiplications in order to make the subjective pair. So it will be pressure volume is equal to nRT. This is what we call an ideal gas equation. So this is the equations formulated and is specifically for ideal gases. So all ideal gases obey this law.